Hello students, I again welcome all of you on this fourth part of the chapter motion of 9th class physics. In up to the third part we have studied about what is the difference between distance and displacement. We have also seen what are the broad points that can be studied under the heading of uh, differences between distance and displacement. Moving little bit ahead, in this fourth part we are going to study about uniform and non-uniform motion. What does it exactly means when an object is performing uniform motion, and when an object is performing non-uniform motion, what does it exactly means, that we are going to study in this fourth part. So you consider any motion of the object, this motion either be, it will be a uniform type of motion or a non-uniform type of motion. Now we will try to understand what is firstly what is called as the uniform motion. So if you look at the definition of the uniform motion, the name itself suggests that there is some kind of uniformity. So if you define this uniform motion, then the definition of the uniform motion tells us that when a body travels equal distances in equal intervals of time, then the motion of the body is considered to be a uniform motion. So here two words are very important, that is this equal distances and equal intervals. Now you will come to know when I will explaining this particular example that I have taken over here. Imagine that you are driving your car on a highway. So imagine that this is nothing but the path on which, or the road on which you are driving the car. So when there is no traffic, there is no obstruction in the road, then obviously you will be moving with no obstacles, and you will drive your car with a very uniform speed. So let's imagine that this particular your motion starts from the point O, that is nothing but the origin point, and I have marked over here from 0, 1, 2, 3, 4 and onwards up to the 20th meter. So let's imagine that your car or maybe any object is moving up to this 20th meter. Now what I did over here, I have made some intervals of the time over here. Let's imagine that some time is required to move from this point O to the point E, that is nothing but the final point. So let's imagine that I have made the intervals of 1 second each. So from here to here 1 second, from here to here it's 1 second, from here to here again it's 1 second, and here to here it's 1 second, and again from here to here it's 1 second. So I have made the intervals at the respective points. Let's imagine point A, point B, point C, point D, and at last point E. So when an object is moving along this particular path, when you are driving the car on the highway, let's imagine that during this time span of 1 second, the object covered, the distance is nothing but 4 meter. So from this particular O up to this point A, this distance is nothing but 4 meter. Again in 1 second, object travel from A to B, that is also the 4 meter. From B to C, again in this 1 second time interval, again the object travels 4 meter. Again from this particular C point to D point, during this 1 second, the object traveled the distance is nothing but 4 meter. So you are seeing that in this repetitive intervals of 1 second each, the object is traveling 4 meter, 4 meter, 4 meter, and so on. That means we can say in this example that the intervals of the time are equal, that is this 1 second, 1 second, 1 second, 1 second, and 1 second. But if you look carefully, during each interval of the time, the object has traveled equal distances. So here also the 4 meter, 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 here also the 4 meter. That means from first interval up to the last interval, the object has covered the equal distances. So we can say that in this example, the object has covered equal distances in equal interval of time. Now if you plot this particular time intervals and the respective distances which is covered in the respective time intervals, and if you plot it in tabulated form, then the table will be like this. Now on left side I have written here time, and it is nothing but the distance covered. So from O to A, during this 1 second, distance covered is nothing but 4 meter. From A to B, the distance covered by the object is nothing but 4 meter. Again from B to C, the distance covered is nothing but 4 meter. And if you move ahead, the same scenario is being repeating up to the E final point. So if you observe this table carefully, you will find that this in each equal interval of the time, the object is traveling an equal distances. So when this such situation arises, that an object travels equal distances but in equal interval of time, then we can say the motion of the object is uniform motion. Now it can be betterly studied with the help of distance versus time graph. If you remember, I told you that we are going to study the motion of the object by graphical presentation also. So if I plot this time on x-axis and distance on y-axis, and I have plotted the respective distance which is covered during each time span, each time interval, then you will see that for one first second the distance covered is nothing but 4 meter. In 2 seconds, that is from O to B, the distance covered is nothing but 8 meter. From O to C, in 3 seconds, the distance covered is nothing but 12 meter. From O up to the D, that is nothing but 4 seconds, the distance covered is nothing but 16 meter. And up to the last, up to the completion of the 5 seconds, the distance covered is nothing but 20 meter. So when we plot the graph of uniform motion, that is equal intervals and equal distances covered, then you will find that we are getting a straight line graph. So it is one of the property of the uniform motion of an object, that when an object is performing the uniform motion, the graph of the object is always a straight line which is passing from the center, and it is inclined to the x-axis. So graph is a straight line. From graph also we can come to know that the object is traveling in such a way that its motion is a uniform motion. Let us try to understand what does it means by when an object is performing a non-uniform motion. The definition is exactly contradictory to the uniform motion. The definition of the non-uniform motion will run like this: when a body covers unequal distances in equal intervals of the time, the motion is called as non-uniform motion. Here also the two words are important. This is unequal distances, and second is nothing but in equal intervals of the time. Now imagine that you are traveling by your car, but the road is not that much clear. That means sometimes you have to apply the brakes, sometimes you have to increase the speed of your car. Then in that particular journey, the equal intervals would be there, but in this equal intervals, the distance covered by the object may not be the same. So here the definition will be run like this: when a body covers unequal distances in equal interval of the time, the motion is called as non-uniform motion. Let us imagine a similar kind of example over here, that suppose the object starts from point O and it is traveling up to this point E. So you are seeing that there are equal intervals, that is 2 second, 2 second, 2 second, 2 second and 2 second, but during each this equal intervals of the 2 second, distance covered by the object is different. So here from O to A, the time interval is nothing but 2 second, but the distance covered is nothing but 2 meter. Again in second time interval, time is 2 second, but now this the object covered is 4 meter. In this next 2 seconds, object covered the distance 1 meter. So in next interval 2 seconds, the object increased the speed and it covered the distance of 5 meter. We are seeing that in each of this same or equal time interval, but the distance covered by the object is not same. So such type of motion is considered as non-uniform motion. Now if I plot the table of this particular motion of an object, you are seeing that from O to A, the time is nothing but 2 seconds, but here the distance covered is nothing but 2 meter. From A to B, it is 2 seconds, the distance covered is nothing but 4 meter. Like that, if you go on plotting, we will see that the total distance covered after each interval of the time, then we will get 2 meter, 6 meter, 7 meter, 12 meter and at last 20 meter. Now if you plot the graph of this non-uniform motion, that is on x-axis I have plotted the time, and on y-axis I have plotted the distance, you will see that in this first 2 seconds the distance covered is nothing but 2 meters. So I have plotted the point over here that in 2 seconds the distance covered is nothing but 2 meter. Now in 4 meter, distance covered is nothing but 6 meter. Total distance covered is 6 meter. So in this 4 meter, the distance covered is 6 meter. Now subsequently, if I go on plotting this particular graph, then the graph is not of uniform, it is not a straight line. When such type of graph appears to be here, it tells us that this particular motion of an object is a non-uniform type of motion of the object. So this is about the uniform and non-uniform motion of the object. In next part we will going to see about the speed and velocity of the object.